Good morning and happy Monday. I don't know if those things even exist, but hopefully they do for you. Hopefully you're going to have a good Monday today. Maybe I'll have a good Monday. Anyways, so this is algebra. This is notes for 2-5, radicals, multiplying, and dividing. So first thing we're starting off with is this weird looking thing over here, which looks a little clunky because obviously it typed it in the computer. When I'm drawing those things, that is going to look something like this. Whoop. So just a little bit more smoother, not as like chunky like that. So let's talk about these things. The first thing to notice is that there is a difference between this. My stylus is being a little sketchy today. Versus this. You know, in one of these, that little itty bitty 3 is smaller. And in this one, this is like a coefficient almost. I don't want to use the word coefficient. This is being multiplied. This is the smaller index, and that's being multiplied. So just notice the difference. That little n there is smaller. I'm scared my stylus is going to break today. I have so much work to do. So let's move on to that. So let's talk about what that n and that a represent. So in this situation, the n represents what is known as the index. And the index tells you what root it is. So like a squared root, a cubed root, a fourth root, a fifth root, a 15th million root, whatever root it is, that little index will tell you that. The a, the piece under the radical, is what's called the radicand. The radicand. And that's just, the number under the radical. Shwoopity whoop. And that shwoopity shwoop that I just so awesomely demonstrated for you is what's called the radical. Or, the root. So, first thing, when we see, because most often we don't see an index written. Most often we just see, something like this right here, which again, I'll give you my version of it. Shwoop, shwoop, just like that. You'll see that. You won't see a number written. We know that when we don't see an index, when there is no index, it is a 2 for a square root. And that is assumed. We always know that. Whenever there's not a number written for the index, we assume it's a square root. We assume that it is a 2. The next thing, I'm just going to turn that into a real life too. So like for here example, I've got a little index of 3. So let's make a note of this. This has an index of 3, which makes it a cubed root. Just like the index of 2 makes that a square root. An index of 4 would make it a fourth root. An index of 5 would make it a fifth root, and so on and so forth. We aren't going to look into anything over a third root, possibly. We're going to focus mostly on square roots, though, this year. So that's a little bit about the vocabulary, surrounding a root or a radical. These radicals and roots, they're the inverse operations. They're the opposite operations of, excuse me, they're the inverse operations of exponents. For example, a square root is the inverse of squaring something. turn that into an actual 2. I keep writing those like z's. There we go. And, you know, the cubed root is the inverse of x cubed, or cubing something. So just things to keep in mind. There's two main directions you're going to get when you are looking at these problems with square roots, and that is to evaluate versus simplifying. And these are two very different things, and it is very, very important that you pay attention to which one the question is asking you to do. So when you're talking about evaluating, evaluate means to, like, plug in your calculator. Plug in your calculator, get a number value. Like, I would take the square root of 25 and plug that in the calculator and get 5. That was a disaster. Okay, now when it's asking you to simplify though, simplifying does not want you to just plug it in the calculator. Simplifying, you are not just plugging it in the calc. You're going to use some rules and stuff that I'm going to teach you about simplifying. And sometimes it means that your final answer will just look something like, you know, the square root of 2, instead of that ugly long decimal when you actually do the square root of 2. So this would be evaluating it, writing down that 1.412 decimal. Just simplifying would be leaving it as the simple square root of 2. So we're going to look at some examples for multiplying and dividing in a moment, because that was a lot.